Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about the main properties of line codes. So based on my previous YouTube video, if you watch that means you have a knowledge about what is meant by communication, how an analog communication is carried out, and how the digital communications are evolved. Then various types of analog communication and digital communications are discussed. Now I am going to discuss about what is meant by line codes and their properties and the various types of representation of line codes. Basic definition: line codes means it is an electrical representation of binary data streams. That is, any digital data, that is zeros and ones, can be represented in a pulse-shaped waveform, that is called line codes. Digital digits are mapped to a pulse waveform. This waveform is called line codes. The important properties of line codes are: it must be in DC component, it is a self-synchronization available method, error detection, bandwidth compression, differential encoding process, noise immunity, spectral compatibility with channel, then transparency. There are various types of representations of digital data in line codings are available. The first and important one is the unipolar NRZ signaling. In this line code, symbol 1 is represented by transmitting a pulse of amplitude A for a duration of the symbol, and the symbol 0 is represented by switching of the pulse as represented in this figure. If you see the figure, if the binary data is 0, then there is no data is transmitted. If the binary data is 1 and it starts from 0 and 1 square pulses are happen and again 1 square pulses are happen, then 0 means no data pulse is transmitted, 1 means 1 unit pulse is transmitted, 0 means no data is transmitted, then again 1 means 1 unit pulse is transmitted. The main disadvantages of this on-off signaling or unipolar NRZ signaling method is it is a waste of power due to transmitted DC level and the fact that the power spectrum of the transmitted signal doesn't approach 0 at 0 frequency. For example, here, even though the 0 will not happen or use of this NRZ signaling, but there is a space wastage is happened here in this method. Even though 0 is not used here, but the space is allocated here. So because of this unipolar NRZ signaling having much higher bandwidth compared to the all other upcoming methods. The next or second line code method is the polar NRZ signaling method. In this second line code of polar NRZ signaling, symbol 1 and 0 are represented by transmitting pulse of amplitude positive A and minus A respectively. If you see the figure, the input binary bit 0, 1, 1, 0, 1, 0, 0, 1 are represented as negative means it starts from minus A, positive means it starts from 0 to plus. So here it is represented in the form of plus A and minus A. The polar NRZ level line code is relatively easy to generate, but its disadvantage is that the power spectrum of the signal is large near 0 frequency. So as like say in the previous method, here also 0 consists no value, but the bandwidth are allocated here. Same thing here also, 0 doesn't contain any information, but the bandwidth are allocated here. So both these methods are having highest power spectrum compared to the next upcoming methods. Next is the unipolar RZ signaling method. In this third line code, symbol 1 is represented by a rectangular pulse of amplitude A with a half symbol width, and symbol 0 is represented by transmitting no pulse. If you see this figure, symbol 0, for example, if the binary data is 0, 1, 1, 0, 1, 0, 0, 1, if it is a unipolar RZ signaling, see this C figure, whenever 0 comes, there is no data is transmitted. So whenever 1 comes, it takes only the half duration of the entire bit. So if you see 1, it will take only the half duration of entire bit. If you can see here, you can visibly see. So the entire bit duration is fully, but for this unipolar RZ signaling, it takes only one half bandwidth. The attractive features of this unipolar RZ line code is that it presents of the delta functions and the power spectrum of the transmitted signal. The delta functions can be used for bit timing recovery at the receiver. However, its disadvantages is that it requires 3 dB more power than polar RZ signaling for the same probability of symbol error. Next method is the bipolar RZ signaling. This line code uses 3 amplitude levels as shown in this figure. Specifically, positive and negative pulses of equal amplitude, both positive A and negative A, are used alternatively for symbol 1, with each pulse having half symbol width. No pulse is always used for symbol 0. A useful property of bipolar RZ signaling is that the power spectrum of the transmitted signal has no DC component and relatively insignificant low frequency components for the case when symbol 1 and 0 occur when equal probability. The bipolar RZ line code is also called alternate mark inversion signaling, that is AMI. So here it is the figure C will show here it is the figure D. The figure D will show the bipolar RZ signaling. Next method and final method is the Manchester code or split phase method. In this method, symbol 1 is represented by a positive pulse of amplitude A followed by a negative pulses of minus A, with both pulses being half symbol wide. For symbol 0, the polarity of these two pulses are reversed. A unique property of the Manchester code is that it suppresses the DC component and has relatively insignificant low frequency components regardless of the signal statistics. This property is essential in some applications. So in this YouTube video, I discussed what is meant by line codes and the various properties of line code and the various types of line code which are used in digital communication. The various line codes are: first, I discussed unipolar NRZ signaling, then polar NRZ signaling, followed by unipolar RZ signaling, bipolar RZ signaling. At the last, I discussed Manchester coding. So next video, I am going to discuss with some new topics in analog digital communication. Thank you for watching my video.